This session will be on attribute and spatial queries. Additionally, I will also be telling you how to link non-spatial data with spatial data, and only will give you a glimpse of the spatial analysis functionalities in QGIS. Again, to start with, we will be working on the demonstration has been prepared using QGIS 2.4. If you go to the website www.qgis.org, you can download the software and use it for your laptop or system. The latest version available currently is 2.10. However, there are no differences that you will find in today's demonstration and the software you are currently getting on the website. You may use QGIS 2.4 or you may use 2.10. The data that has been provided and the slides shown here will work for both the versions. So as I said, what we will be covering today, non-spatial queries and spatial queries, and linking spatial and non-spatial data. So as you know by now, we have you have gone through some GIS lectures. You now understand what is GIS data, what is rasters, what is vectors, what is georeferencing, how you can digitize some data, how to create spatial data. And now once your GIS database is ready, how you can do some analysis on the GIS data using this QGIS software is what I am going to show you today. Now, the data for today's software has been derived from the data available on this website www.naturalerthdata.com. There is no spaces, gaps, hyphen, dot, etc. between natural earth data. This is one single word. And a lot of shape files are available at different scales, country boundaries, rivers, islands, water bodies, and a lot of physical as well as cultural data at different scales is available on this website, free of cost. You can download and use it. So the website is www.naturalerthdata.com. You can go to this website and download the data sets, or you can go to the FTP site and download the data for today's exercise. The software that we are using is QGIS, which you can again download from FTP or from the website given here, qgis.org. Now, there are different types of operations that can be performed in a GIS environment. All of the GIS operations can be done using the QGIS software. To start with, the first basic thing that people want to do with a GIS software is to make some measurements. So here I am showing you some of the features. These can be used in any manner, depends on your imagination. So the first thing is the distance measurement options. For that, there is a measurement tool which is available, and it appears right here on top of the software in an icon which looks like a ruler scale that you use in school. If you click on the arrow next to the ruler, you will see three options that come in the drop down. First is measure line. That is, you can measure straight line distances. Second is measure area. That is, you can draw an area of interest, a polygon, and you can measure the area that the polygon that you have drawn occupies. And the third option is angle. You can measure the angle between two lines. So here I have added some data set which are showing the two rivers Yamuna and Ganga, and are showing the three city point locations, Muradabad, Meerut and New Delhi. And if I click on this option here, make measurements, measurement tool, select the first option, measure line, left click once on New Delhi and then left click again on the next point, let's say Muradabad, a box will pop up which will say measure on the top, and you can see that the uh, distance, the straight line distance, or as they call as the crow flies, distance comes up in this box here. There are options to change the units, meters, kilometers, feet, etc. Or if the data is in, so coming back to one of our earlier exercises, somebody asked, what is the use of reprojecting data? So in this case, let's say your city data is in lat long. Then the measurement that you are making will come in degrees. So you may require to change the projection system of your project to a projected coordinate system so as to make measurements in metric units. So that is regarding the first tool, that is using measurement tool. The second and a more powerful option is the export add geometry columns tool. Where would you find this? In the menu options, the option for vector. If you click on that, on the drop down, the second last option is geometry tools. If you click on that, a sub menu opens, and the second option from top says export/add geometry columns. If you click on that, a box comes up which says export add geometry columns on the top. It will then give you a drop down listing all the vector layers that you have added inside your GIS environment. And then it allows you to save the file with the new geometry columns as a new file. Or if you do not select this option here, save to new file, if you do not enable it, it will update the existing file. So what are these geometry columns? They differ depending on what kind of shapefile you are using for in this tool. If your shapefile is of point type, then this tool, export add geometry columns, will add the X and Y coordinates, that is your longitude and latitude coordinate, in as a column in your attribute table. Okay. If the shapefile is of line type, then this tool will add the length. So as you are seeing here, I have applied this tool to this layer called India rivers. As you can guess, the river has been prepared as a line shapefile, and when I run this tool, I get a new file with an updated attribute table with a new column called as length automatically generated, and the length of the rivers in meters are populated. If the shapefile is of type polygon, then this tool will generate two columns. First column is of the area, that means for each polygon in how much area it occupies will be listed, and the second column will be of perimeter, and what is the perimeter of each polygon will be populated in the second column. So I will just repeat. Using this tool, export add geometry columns will give three kinds of results depending on kind of shapefile you are using. For point data, it will generate two columns and populate it with the x and y of each point. If it is line, then it will generate one column and it will give the length of each line. If the shapefile is of type polygon, it will generate two columns and it will populate with area of each polygon and perimeter of each polygon. Now, there is another option of importance here, which is saying calculate using, and then there is a drop down. This drop down has three values: layer CRS, project CRS, and ellipsoid. What does that mean? CRS, as you know, stands for Coordinate Reference System. And as I said, all the measurements will be made in the coordinate reference system of the file itself. So if the file is in a projected coordinate system, or let's say it is in UTM, then all the data such as length will come in meters and area will come in meters square. If the data is in geographic coordinate system, let us say lat long, then the length will come in degrees and the area will come in degree square, which may not be of use to you. Hence, there are two ways you can get the values in metric quantities. One, you can reproject the data to UTM, which was shown in the georeferencing exercise, or you can simply change the CRS of the project by going to settings, project properties, and changing the project coordinate reference system, and select the second option in this drop down which says project CRS. That will also result in these quantities in metric units without having to reproject the original data set. Now coming to the third technique using which we make digital distance measurements, which is called the distance matrix. This is generally used for point data, where if you have, let's say, n number of points, then all the distance from each point to n minus 1 other points can be listed like a table shown here. It can be generated in a single tool. The tool is called distance matrix, and you will find it under the menu option vector. In the drop down, there is an option for analysis tools, and if you go here, there is a sub option which says distance matrix. If you click on it, a box will open which says distance matrix. You can find distances between two different layers, points in two different layers, or you can specify the same layer in both the drop downs. One is for input point layer, the other one is for target point layer. It finds the distance from all points. Let's say there are n points in the input point layer and m points in the target point layer. Then it generates a n by m matrix where all the distance between all the n points to all the m points are found as shown in this table here. Interestingly, if you look very closely, you will note that the distances here seem to be incorrect. It says the distance between Jammu to Ludhiana is 2 point something, which obviously is ambiguous because this cannot be 2 meters, 2 kilometers. The answer is that the data here, Indian cities, is in geographic coordinate system. Hence, all the measurements were done in degrees. This is the distance between Jammu and Ludhiana is 2 point some degrees, which obviously is not very useful. You would want the distance in meters or kilometers. So to fix this thing, fix this problem, you need to reproject your data to a projected coordinate system and then perform the same analysis again to get the distance in meters. The next set of analysis that you can do is to select features and save them as a different layer. Generally, so if you are downloading data from Natural Earth, you will see that the whole world data is given to you. You are interested in only to do a study within India or within a specific country or area, and you would only require features or polygons or lines within your subject area, and you want to save it as a separate file. You don't want to use the whole global file. Then how do you do the selection and how you save them? There are two types of selection. One is manual, one is automatic. First, we will see how to select manually. To select manually, you will see an option like this in the buttons on top in QGIS. This, if you bring your mouse on top, it will give a text which says select feature by. If you click on this option here, in this arrow here, a drop down will come with 5 options. Select single feature, select features by rectangle, select features by polygon, select features by freehand, and select features by radius. All these options basically imply that with your mouse you can click on the data set which is displayed in map canvas and select polygons manually or select features manually. So for example, if you select this option, select feature by rectangle, it allows you to click, drag and draw a rectangle in your map canvas. And all the polygons or all the features which will touch or come within the rectangle, even touch, need not come completely within the rectangle. If it is halfway outside, halfway inside, also then all the features which touch the rectangle will be selected. Similarly, if you want to draw an irregular shaped polygon, you can select the third option which says select features by polygon. Similarly, the fourth and fifth option. This is selecting the data by viewing it on the map canvas and clicking on it. The second option to select features is by looking at the attribute table. If you know that the feature has a specific name or specific quantity attached to it in the attribute table, you can select it by looking at the attribute table. How do you do that? You right click on the layer, click on open attribute table, and you view the data like this. And let's say you want to select all the rivers. This is the attribute table for India river. If you want to select all the rivers that have the name Krishna, you simply click on the number. You see the numbers here, 0, 1, 2, 3 and so on till 11. Simply click on 0. Then you want to select this also. You press Ctrl CTRL button on your keyboard and then again click on this number 9 here to select 2 rows, 0th row and the 9th row. Okay, so these are two different mechanisms by which you can select the features manually. Once the feature has been selected, you would want to save it as a new file. How do you do that? You simply right click on the layer, go to the option which says save as. A box will come, a new window will come which says save vector layer as. In this, there is a checkbox which by default is disabled. You have to enable this, which says save only selected features. That means create a new file based on the features that you just selected, either by clicking on the map canvas or by selecting them in the attribute table. Once you have selected it, saved it, you would wish to deselect the features. To do that, there is a separate button on top of the uh, just below the menu options, which looks like this, encircled in red. Click on that, and when you bring your mouse on top of it, it says deselect features from all layers. If you click on that, all the selections that you have made will be removed. All the selected features will be unselected. That means no feature will be selected. Now we come to attribute query, also called non-spatial queries. Now, how do I perform non-spatial queries in QGIS? There are two mechanisms. One mechanism is by clicking on this menu option layer, and below towards the end there is a option called query. You can use this, or in the attribute table for each layer, if you right click on the layer, click on view attribute table, on the bottom left you will see a box which says show all features. If you click on it, on the end of it, it says advanced filter within bracket expression. So these are the two mechanisms mainly. This advanced filter can also be opened by clicking on this button here, which is numbered as 3 and has the summation sign written on top of the button. To open the, you can click on this button to open the advanced filter. However, these two tools, the layer query and the advanced filter, although they select features by query, they do not perform the same task. I will be showing you in the following slides. So let's look at the first option, that is clicking on the layer menu option and selecting query. Once you click on that, a box will come which says query builder. Here it will list all the attributes of that layer. So in case you are not very acquainted with what non-spatial queries are, what we are doing here refers to vector data only. Okay, so non-spatial queries refer to vector data where the attribute table associated with each vector layer can be filtered. You may have used Excel or some spreadsheet application where you have many data sets in rows and you want to select some rows based on some filter. That kind of applications can be done on the attribute table you have for each feature layer. To specify what kind of filter you want to apply, you have to write a query. The query is very simple in nature. Simply you can write, I want to select all the lines which are greater than 100 kilometers. So you need to just double click on the attribute which specifies the length of your lines. Here there is a button for greater than, and simply you can click here and type 1100, whatever limit you want to apply, and say OK. This will select all the lines in your line layer which are greater than a specified distance. Similarly, let's say I have here the boundaries for all the countries in the world. Along with that, in the attribute table, I have information such as the population of each country and the GDP of each country. I want to filter, or I want to select only those countries which have a population of greater than 100 million and a GDP which is greater than this is what 2 into 10 to the power 6 million USD. So I want to only select the countries which meet this criteria and possibly save it as a new layer or carry out my further analysis. To help you do the exercise, although the data has been provided, a nice little project has been created with the data and kept it on today's data in the FTP link. Just need to double click on this file called example01.qgs. Once you double click on this, QGIS will automatically open and the layer that we need to work with will already be added. Okay. The name of the layer that we are working with is NE50M admin 0 countries. Just right click on the name of the layer, or sorry, select it and click on layer, then query, and in the box which pops up, just type the query which is written here, or you can create it also. Double click on the column which gives an estimate of population, then the greater than sign, and then type the value 100 million, then write and. You possibly know about Boolean operations and, or, and not. So you can combine multiple queries using and, or, not to get different results. And then double click on the column which says GDP in $1 million estimates greater than 2 into 10 to the power 6 or 2 followed by 6 zeros, and click on OK. Once you type this query or create this query and click on OK, you will see that the rest of the countries in the world are removed or somehow hidden, and only the countries which match your criteria will be shown. Unlike selection done using manual or other automatic methods, in those methods only the selected features get highlighted. Using this option, layer query, only the selected features will be shown and the rest of the features will be hidden. They will not be deleted. They will remain there, but it will be hidden till your analysis is complete. Now let's look at the other type of attribute query option, which comes in the attribute table itself on the bottom left. As I told you, if you click on this box which says show all features, you will see an option called advanced filter. Now let's say I want to filter all the countries that have the name which have land in their name. For example, I want to select Greenland or Iceland and such countries which have land in the name. This is just an example query. You can develop your own queries. Again, to do this, you can simply double click on this file provided to you, example01.qgs. Right click on the layer, click on attribute table. The attribute table will come up. On the bottom left, you will see this option show all features. Click on that and then select advanced filter. You will see a dialog, a window come, looks like this, expression based filter. And then here you can type the query. The query here is name, which is the name of the column, name. I like, which means which is an operator to do matching based for columns which have text data. That means this is the operator which will run on this column called name and search for expressions which look like this. That means can have 0 or more characters before land and after land. Okay. So you can see in this attribute table here, all the columns which have the name land get selected. The countries include Antarctic land, Switzerland, Finland, Greenland, and even countries which do not have only land at the end. They have, for example, Netherlands. There is an S at the end. Hence, this expression is doing what we want it to do. Can have 0 or more characters before the term land or before the string land, and can have 0 or more characters after the string land. Okay, so this is just an example of what kind of query can be performed. The query can be arithmetic in nature. You want areas which are greater than a certain value, lengths which are less than a certain value. You can have text based queries. For example, the one showed, you have a road network and you want to select all the roads which have the name something highway, which have the name uh, percentage highway. So anything which has highway in the name will come. Even complex queries can be written using this expression based filter. Those of you who are little bit into computer science can do possibly Python programming. There are options in this expression based filter which allow you to write Python functions to filter the data and select the required features. That is only in case you want to write complex queries. Now we come to the second most important and most highly cited GIS operation called spatial queries. Till now we saw non-spatial queries, also called attribute queries. Now we come to spatial queries. Generally, spatial queries are called multi-layer queries. That means there are two layers or two vector data sets, two shape files which are required to do a query. Now, as the name suggests, there is some kind of spatial operation, some kind of spatial relationship that must exist between the two layers. So, for example, in this demonstration, we ask a question, give me all the cities or find all cities that are within 10,000 meters, that is 10 kilometers from rivers. Now, To do any GIS task, once you have seen a question, you should first ask yourself, what are the data sets that we need? So first thing that we will need is the cities layer. So you should have the cities in your study area, point data for all the cities. The second thing that you should have is the rivers layer. That is a line layer which shows the rivers of your study area. From this rivers line layer, we will generate a polygon layer which is a 10,000 meter buffer. The word buffer is, I am talking about the GIS operation buffer that we will apply to this rivers layer and generate a polygon. If you see carefully here, it shows a polygon around which is 10 kilometers on both sides, both banks of the river along the entire length, and it will generate that buffer along the river. And then using the buffer and the cities layer, we shall perform the operation spatial query and find out all the cities that are within, I'm saying within with emphasis because within is the word, is the keyword that we will select in the spatial query tool. So that is the picture I'm trying to paint to solve this objective, that is to find all cities within 10,000 meters of rivers. So let us see stepwise what are the operations that we need to perform. To facilitate you to perform the demonstration, you can double click on example02.qgis file. Then the first step that we will perform is to create a buffer. This buffer is actually a spatial analysis feature, and this is available in the drop down in the menu option vector. If you click, then you have to go to geoprocessing tools, and then you have to click on buffers. Once you click on this, a box will come as shown here, and you have to select the Indian rivers of layer in this drop down. Give the buffer distance as 10,000 and then give the name of the output file. This radio button, this checkbox here which says dissolve buffer results will help you dissolve polygons if they overlap. So you have two rivers, or if there is a river with multiple tributaries, if you draw the buffer of the entire river with its tributaries, many of the buffers may overlap, especially where the tributary is meeting the main river. In case you want to dissolve both these polygons, these two polygons, to create one single polygon, you should select this option, dissolve buffer results. Once you click on OK, a data set like this will be created, that is a 10-kilometer buffer along all the rivers, all the Indian rivers that are available in this data set will be created and added to the canvas. The next thing we want to do is to actually perform the spatial query. Till here we were doing the buffer operation to just create the buffer. To do the spatial query, we have a tool called spatial query. You will find this under the menu option vector. In the drop down, there is an option for spatial query. If you go here, there is a sub option which says another spatial query. If you click on it, you will see a box which appears something like this. A dialog which says spatial query on the top. Here in the source feature, select Indian cities. In the reference features, select a river buffer. And in the operation here, where the feature, select within. So what are we doing here? We want to select all the Indian cities that are within the 10-kilometer river buffer that we just created using the buffer tool. Similarly, this option here has many other options like touches, completely within, outside, inside, and so on. You can experiment them. So once you select these three options, Indian cities within and river buffer, and click on OK, a box will come like this, which will say that it has found 15 of 600, or sorry, 15 of 65 features that are matching. So there are in all 65 Indian cities in the data which has been provided, and 15 of them lie within the 10-kilometer buffer, river buffer that we created. And it has selected them using this button here marked with 5. You click on it, you can uh, you can save these cities as a new layer. After so you see, initially we had two layers, India river and Indian cities. Uh, the India river is selected and shown with a blue line. So all the blue lines that you see here are the rivers that are in this data set. The Indian cities layer has been checked off. That means although the cities layer is there in this project, but it is not being displayed. Then we created the river buffer, a 10-kilometer buffer along each of these rivers. It has been created and it is there, but it is not being displayed. It has been turned off. As you can see here, the X sign is not there. And then based on the buffer and the Indian cities, we performed a spatial query and we created a new layer out of the selected results and saved it as Indian cities selected. And that is being displayed here. So these are the rivers, and all the cities that are being viewed that can be seen are the cities that lie within the 10-kilometer buffer of the data set. There could be other cities, but this data set only had these cities, hence the result. These are not the only cities. If somebody is looking for that. The next thing that a lot of people have this query, how do I link? I have lot of data in tables, in Excel files, in spreadsheets, and in ASCII format, in Notepad. How do I add that data in GIS? How do I link that data with my GIS data? So there are two ways to do that. One, in case your data has geometry information, that means it is point data and it has the coordinates of the points, then you can create a point layer out of the text data that you have. The second option is, in case the data set does not have the geometry information, then also the linking can be done. It will be shown in the next slide. So the data for this exercise is provided to you in this file example03-data.csv. It is there in today's folder. Even if you do not have this file, you can simply create an Excel sheet or you possibly already have a lot of data which you have collected from field, which has your latitudes, your longitudes, and some other data set in different columns. You can store it in a notepad file or in an Excel file or any other spreadsheet application. And click on File, Save As, and save it as a comma separated values file or a CSV file. How do you do that? You simply click on File, go to Save As, and in this option here, which by default we select as Excel worksheet, click on that, a drop down will come, and somewhere below you will see an option called CSV, a comma separated values file. Click on that, give any name and say save. Then in your GIS environment, in QGIS, if you click on the menu option layer, towards the end, I think the last or the second last option is add delimited text layer. Remember this option, add delimited text layer. If you click on this, a new dialog will come, a box will come which says create a layer from a delimited text file. Here in the first option for file name, click on browse and select the file that you created from Excel here. The CSV file that you created from Excel, you specify that by clicking on browse option here. Tell QGIS that this is a CSV file. Then make sure you specify that this option geometry definition is selected to point coordinates. This radio button for point coordinates must be selected. Once you select this, it will ask you which field. So as you can see here, there are 3 columns or 3 fields. Which field specifies the X and which field specifies the Y. So you select the header or the name of the column which specifies the X and the Y and click on OK. So there are 4 things that you're doing here. One, you're clicking on browse and selecting the CSV file. Second, you specify the file format. You tell the GIS that this is a CSV file. 3, you specify the point coordinate. The geometry definition is as a point coordinate. And 4, you specify the X and the Y field. Once these 4 things are done, once you click on Y, the data that you are seeing in Excel sheet will be converted to a point shape file. So as you saw in the previous slide, these were basically coordinates of some villages in Odisha. So I went on field, I took my GPS along with me, and I went to these villages. I went to some of the wells and took their coordinates from my GPS and noted it down in my laptop in an Excel sheet and saved it. And then I came to the lab and I said save as a CSV file, opened the data in QGIS using add delimited text layer, and now I have a point file for all the wells that I saw in different villages in the Jaipur district of Odisha. Here, by default, the coordinates that you write will be set to geographic lat long. In case, generally it will not happen, but in case you have the coordinates in any other projection system, you can also specify that by searching for the appropriate coordinate system. clicking on it and saying OK. So this is with regard to linking or creating spatial data from an Excel sheet, from some kind of non-spatial data. The second thing which I want to show you is without geometry. In case you have some data set which does not have the latitude longitudes, but there is some data which you want to join with existing GIS data or existing feature layer or vector layer that you have. So in this case, what I am trying to show is, let's say I have a point layer which are basically points, and each point is the name of the block so for each point in the attribute table, the name of the block has been specified. Now I have another CSV file. This is also given to you in today's dataset called welldata.csv. This file has the name of the blocks and the depth of the water table in these blocks. So I went on field, I noted the information in Excel sheet, the name of the block and the depth of the water table. Again, the name of the block and the depth of the water table. I came back to my lab and I see that I have a polygon or point layer of my block file. But I want to integrate the information that I got on field, which is in my Excel sheet, to my GIS vector data. So there has to be a column, a field, which is common in both the vector layer and as well as your Excel sheet. In this case, it is the name of the block. Okay, the block names are the same in my vector data as well as in my Excel sheet. And then I do what is known as a join. So how do I do that? For your convenience, the data is already added and a project has been compiled called example03.qgs. You simply double click on it. Then you click on layer and add delimited text layer. Select the file which I have given to you, welldata.csv. Now, in the last case, if you remember, in geometry, we selected point geometry. Let me just bring up that option for you for 1 second. In the geometry definition, here we had selected point coordinates. But for the next example, you will select this option here, which says no geometry. So select no geometry and click on OK. It will get added. Then right click on the point layer which I have given to you called villages. Go to properties. Click on this option called joins. Then click on this icon, green colored icon on the bottom which says plus. And as soon as you click on plus, a box like this will come which says add vector join. Here you select the join layer. That means the name of the Excel sheet. You select the field in both the feature layer, that is your shapefile, as well as your Excel sheet, based on which the join has to be performed, and click on OK. Once this is done, all the data from the Excel sheet will be copied into your shapefile. That means your shapefile will now have additional columns which have been derived or which have been copied from the Excel sheet based on the column values. So when the village name is same in the, or the block name is the same in the shapefile as well as the Excel sheet, the data corresponding to it is added in the shapefile next to the existing attributes. So this is about linking spatial and non-spatial data with and without geometry. Now, let me give you a small glimpse of the powerful spatial analysis functionalities that QGIS have inbuilt. So if you click on vector in your menu options, you will see 4 sub options: research tools, geoprocessing tools, geometry tools, and data management tools. And most of your vector-based spatial analysis needs can be performed using these 4 options and its sub options. So a lot of modeling is done sample based. You do not generally perform a model for the entire area. You take some sample points and then you run. So you want to randomly select some points. That can be done using this tool here which says random selection. Similarly, you want to generate some random points in your study area. Then you use this tool called random points. You want to divide the area in regular grids and then do your models or use it for your visualization. Then you use this option vector grid. And you want to generate a polygon from a layer extent. You want to generate a polygon based on an existing layer. You use this option here or this tool here which says polygon from layer extent. The second sub option, geoprocessing tools, is where all the spatial analysis, generally all the GIS operations that can be performed, such as buffer, intersect. If you have 2 layers, all the common features, intersecting features, will be saved as a 3rd layer. Union of features in 2 layers can be saved as a 3rd layer. Clip, you want to remove features from a layer based on a 2nd layer. You want to dissolve multiple features. All these operations can be done in using the tools under geoprocessing tools. The third option, geometry tools, is where you perform all your geometrical related operations, such as export and add geometry columns that we saw. You wish to generate polygon centroids. You have village boundaries and you want a point for your village, a point map. You do a polygon centroids. You want to do Delaunay's triangulation. You have points and you want to create a tin. You want to simplify geometries. You have very jagged edges in your polygon and you want to create smooth surfaces or smooth boundaries. You simplify the geometry. You want to convert your lines to polygons. Generally using a GPS, you create a track, which is a line. But you want to convert that to a polygon. You use this tool, lines to polygons. So most of your basic GIS tasks can be done using the spatial analysis options available under the vector menu. Now let us have a glimpse of all the raster-based spatial analysis features that you have. So too many small font here. In the raster menu, you will see the first option, the raster calculator. Somebody asked me the other day, how do I calculate the indices, NDVI, NDSI, etc. Use the raster calculator here. You want to reproject data. You want to change the projection system. You want to resample it, or you want to convert the no data values into some other value. You want to create a mask layer. You want to create a raster of specific dimensions, n number of rows and m number of columns. All that can be done using this option here called warp, WARP, that is warp, which comes under this submenu called projections. Under raster, there is a third option which says conversion. Inside conversion, you have the options of rasterize and polygonize. You want to convert your raster into vector, you want to convert your vector into raster. All that is possible using this. You want to convert the format of your images, you want to convert RGB to PCT and vice versa. All those types of conversions are possible here. The next option is for analysis. You want to do a sieve. You want to filter out raster values based on some condition. You want to fill the no data. You want to do a proximity analysis. You want to do DEM based operations. All that is possible in this analysis sub option. The grid within bracket interpolation tool is very powerful. It allows you to do interpolation in 4 different algorithms. IDW, that is inverse distance weighted, nearest neighbor, data metrics, moving average. It allows, grid interpolation tool allows you to interpolate or resample your data in using 4 different interpolation techniques. And talking about terrain analysis, just look at the list of terrain analysis operations that you can do using QGIS. Let me just read out the subheadings. Terrain analysis for channel networks, terrain analysis specifically for hydrology, terrain analysis for lighting based tasks such as hill shading, sky view factor, topographic connection, terrain analysis for morphometric calculations, terrain analysis for profile calculation. So there are many tools and operations that can be performed using QGIS, and this is just a glimpse of it. Apart from what has been shown, QGIS has many more features. It is equivalent, if not better, than any other GIS software which you either buy or crack or borrow it from your friends. It allows you to do complex tasks such as network analysis. You can build topology on your vector data sets. You can do all kinds of terrain analysis, as we saw. If you have some idea about GRASS, which is one of the oldest GIS software and it is very powerful, all the functions of GRASS can be performed from within QGIS. You need not separately install GRASS, and all the functions of Saga, Orfeo, these are different GIS remote sensing tools. All the functions that are available in these tools can be performed from within QGIS. Some of you may be aware of options called model builder. That means you want to build a model based on multiple tools. You want to join them. You want to create a chain out of it. I want to first clip the data, then resample it, then divide it by 10, and then apply some other algorithm and get output. All these can be chained together in one single model using the model builder, which is also available in QGIS. And if you are a little bit into computer science, need not be a very good programmer or anything. If you know a little bit of C++ or Python, Python is a very simple language. You can customize QGIS. You can create your own tools. At IARS, we are developing lot of customized tools in QGIS for different tasks, which you can explore. So this is just a brief about the very powerful QGIS software. You can explore it further and feel free to come back to me at this email address for any doubts you have regarding QGIS or GIS in general.